Welcome back. In this chapter, we'll study matrices, a very common LCAT topic in which you just can apply formula and find the results. So, no more tricks. In this topic, your understanding is the crucial factor which determines whether you would be able to crack those questions or not. First of all, matrix is in general in this form, like written in the square brackets. Now, the small a is the element, and one states that it's in the first row and in the first column. Similarly, A12 means the first row, so we are like in the first row, but now in the second column. Similarly, A13 and so on and so forth. And if we move downward, it would be A21, now it's second row, first column, similarly A22, and so on and so forth. We can go up till AN, let's say M, where M is the last row, and N on the columns. So where N is the last column. So A2N and similarly AMN. We also represent matrices with capital letters such that capital A. Order of a matrix is equals to the number of rows you don't have to multiply them, you just write them in this format. For example, if we have a matrix like matrix C, then what is the order of matrix C? It's just the number of rows. There are two rows, one, two, two cross three columns, one, two, three, so two cross three. Just write it as it is. You don't have to multiply that. Even if you multiply, that would be incorrect. So you have to use. They will check if you understand this concept or not. So they will give you 2 by 3 and then a 6, and you have to choose 2 by 3. Even if it's not two cross three, it's like the same thing as if you say 2 by 3. That both works, but the 6 does not work here. So the next most important thing are the type of the matrices. The most frequent occurring in LCAT is the square matrix. It is a matrix which has equal number of rows and columns. For example, matrix A since it has two rows and two columns, and the order is 2 cross 2 or 2 by 2. And the special thing about square matrices is that you can find the determinant very easily. Hence, then determinant of A times D is diagonal minus B times C. Yeah, that's straightforward. What could be the determinant of C? It could be 2 times 5, which is 10, minus 4 times 3, which is 12. It's negative 2. The next most important concept is adjoint of a matrix. Specifically 2 by 2 matrix. So adjoint of A is represented by ABGA, and it's just that you swap, you diagnose the DA and change the signs of the other two. Then the adjoint of 3 would be equals to, we first change the positions for 4 and 1, and then you change the signs, the remaining -3 and -2. Now, once you know the adjoint and the determinant, the next important step is inverse of a matrix right now, or 2 by 2 matrix. On our element of A times adjoint of A. And since you know that side of A is D minus E minus CA, we can write that as well. Hence, we'll start by finding determinant. The determinant of A can be represented by DEA or simply A with 2 bars on the right and left. And it's just represented 2 bars instead of square brackets, and then 2 times 0 is 0, minus 5 times 3 is 15, so it's a negative 15. And if we use this formula, we know that A is 2, so we'll replace it with 2, D is 0, -3 and -5. Similarly, the determinant of A is -15. Hence, this is the answer for A inverse. You can further multiply 1 over 15 inside the matrix to make it 0, -3 over 15. Like that. And you can even simplify it further. So -1 over 5. Like that. This is how you calculate inverse of a matrix for 2 by 2 matrix. Now, there is a case when determinant of A becomes equal to 0. Well, in that case, the inverse does not exist, because if determinant of A is 0 and you're trying to find the inverse, you should have 1 over determinant of A, which is now 0, which gives you an undefined answer no matter whatever is adjoint. So that's why you cannot move further. And there are some kind of questions in LCAT where they ask you to find inverse of a matrix, and then you would see options, but then there's an option that says does not exist. And more often you are busy finding that joint first that you don't even realize that the determinant is actually 0, and you can just move to the next question by selecting that does not exist. Hence, for every question, first find determinant and then After if determinant is not equal to 0, then go to adjoint and then go to inverse.